Hey everyone, and welcome back to section 5.3. We got some more examples of multiplying polynomials, and every time we do it, we're going to step up in complexity a little bit. So, first example, right off the bat, we are going to be multiplying binomial with a trinomial. Now, the FOIL method really worked because we had 4 terms total in the expression. We can't use the same acronym, obviously, but we can use a similar approach. What does scale up exactly the same is this vertical method. So we've got 4 times 5, which is 20. Then we have 4 times negative 3x, which is negative 12x. Then we have 4 times 2x squared gives me 8x squared. Move over a space. X times 5 is positive 5x. X times negative 3x is negative 3x squared. And finally, x times 2x squared gives me 2x cubed. So that one wasn't too bad. Now we have a trinomial times a trinomial. And so obviously the more terms that you're putting in, the longer it's going to take. But this multiplication works exactly the same way. Now, I would just like to point out here that in using this vertical method, we want to make sure that the polynomial that we're using is in decreasing exponent order. And even though we've got a third term, we proceed exactly the same way. So we're going to have 3x squared times negative 8. And then we're going to collect like terms by adding straight downward. And there we have it. All right, now let's look at some so-called special products. First up, we have the quantity x plus y squared. Now, I'm going to write something here that's incorrect. What I'm about to do is very dangerous. It should only be done by a certified professional. I am a certified professional, and I'm illustrating what you should not do. X plus y, quantity squared is equal to x squared plus y squared. This is something we call the freshman's dream in mathematics because it's something that arises a lot in these elementary algebra classes. So do not do this. In fact, I think even just the mention of doing this makes my dog upset. So what's the proper way to approach it? Remember that a number squared is the number times itself. So to square x plus y properly, we write x plus y times x plus y. And we can follow FOIL. And since multiplication is commutative, xy and yx are the same thing. So they're actually like terms. Next up, we have x minus y squared. Again, you do not want to write x squared minus y squared. Using FOIL, be careful of signs. Again, xy and yx are like terms. And so we really get x squared minus 2xy plus y squared. And lastly here we have x plus y times x minus y. Let's go ahead and multiply those guys together. Aha! So this is x squared minus y squared. But if you try to pull that nonsense with either of these other two problems, you're going to be missing these middle terms. And, you know, we don't want to make anybody upset, especially not me. So be careful whenever you're multiplying. And finally, bringing it all together, we are going to combine a bunch of stuff into one expression. And we want to simplify each of these. So these are pretty gnarly, but let's give it a try and see how it goes. All right, on the left-hand side here, I have multiplication. And then over here, I have another multiplication. Order of operations says I have to do that before I add them together. So I'm going to distribute. Okay, that wasn't so bad. Plus, and now I am using FOIL here. Then we clean up and combine like terms. Great. Okay, now I see here that I have a binomial times a trinomial in the next one. So we're going to do some side work to figure out what that is. All right, and keep in mind here, you know, you want all of the terms to match up. So the constants in the first column, the exponent 1 terms in the second column, squared terms in the third, and so on and so forth. Now you might be wondering, why are we doing this all by itself? Why don't we just do everything at once? That's a very good question, imaginary person. So what we have to be aware of is that we are subtracting the entirety of 2k plus 3 times k squared plus 2k minus 4. So that means that this negative sign has to be accounted for. Okay, we gotta distribute. And there we have it. So that's all for multiplying polynomials. Again, we just want to keep practicing. Practice makes perfect. It's going to take tons of examples for you to feel comfortable with doing this. But once it clicks, it really clicks. All right, and in the next video, we're going to be looking at dividing polynomials.